The drawing represents a design for a water storage tank. Okay, storage. In terms of pi, how much volume in cubic meters of water can it hold? Now, there's a lot of clues in this reading that you won't get on ACP. You need to know that when it's asking how much something can hold, that's volume. Now, I've seen questions like this where the volume is omitted and it asks how much water can it hold. That's volume. All right, now we have three shapes here that you should be able to recognize at this point. We have two identical cones on each end and one cylinder, and we're doing volume. And you want to look up the cone and the cylinder formula. Okay, there they are right there. Go ahead and get all that wrote down. Okay, so 1/3 pi r squared h for the cone and pi r squared h for the cylinder. Get started here. We got two of those, so we're going to say 2 times 1/3. Okay, I'm doing cone, and the cone is 1/3 pi r squared h, and then we want to add in that cylinder, which is pi r squared h. Okay, that's your formula. What is the radius of the cones? Okay, right here. It's pointing to this section right there. That is your radius. So the radius for both cones, 6. Now the height must be that vertical piece that goes from the tip of the cone to the middle of the base. So that's our height. So in this problem we know that the height, we have it, it's 8. And the height of the cylinder we know is 20, and we also know the radius for the cylinder. So the 6 will be the radius for both cone and cylinder. All right, so go ahead and find me the answer here by doing 2 times 1/3 times in terms of pi. At this point, every time before I go get the formulas, but before I do something with pi, I read again in terms of pi. So let's take it out, and we're only going to work with this formula without the pi, but put it back in. You'll see the answer choices has pi in it. So we're going to put 6 squared, I'm working with the cones, times 8, okay? All right, all this right here, 2 times 1/3, okay, times 6 squared times 8. That's representing both cones. Plus, and then take out the pi, right? So the radius is the same for both, 6 squared. Now the height of the cylinder is, that's right, 20. Okay? Put all that in the calculator just like that. Now to take care of it.